No, there has been a huge rise in the number of IoT devices in the recent years. According to Statista, the expected number of devices are going to be approximately 30 billion by 2020. This has led to a new emerging type of DDoS attack called low-rate DDoS attack. In low-rate DDoS attack, there is a slight increase in the packet rate from a large number of devices. Because of this, traditional filter-based methods fail to work. Another factor which makes DDoS attack more threatening is the recent rise in the widely distributed nature of the attacks. The figure shown is the geographic distribution of Mirai infected devices. As we can see, the devices are spread all over the world. The problem that we are trying to address here is a distributed low rate DDoS attack in which millions of compromised devices target a server simultaneously. Such an attack would be difficult to detect at a local level since there is a small increase in the net traffic from infected devices. Moreover, it is extremely difficult to mitigate such an attack as the devices are so widely distributed. Audit acts as a local solution and hence can detect and mitigate the devices causing the attack. Now let us take a look at some of the challenges that make DDoS attack detection and mitigation so difficult. The first challenge is timely detection. We need the attack to be detected in minimum time while satisfying a false alarm constraint. The second challenge is minimally invasive mitigation. The attack should be stopped without any interruption to service to nominal users. The third challenge is unknown attack patterns. We need the IDS to detect unknown or previously unseen attacks. The fourth challenge is scalability. The IDS should be able to scale well so as to account for millions of devices as well as not be computationally too expensive. Now let us take a look at the proposed intrusion detection system called Online Discrepancy Test or audit and how it solves the previously mentioned challenges. The first challenge was timely detection. Audit is an online sequential algorithm which accumulates evidence instead of making a hard decision and thus timely detects the attack while minimizing the false alarm constraint. The second challenge was minimally invasive mitigation. Audit does not block traffic from all users. Instead, it computes a mitigation statistic and detects anomalous users based on it. Then it blocks traffic from such users by filtering or similar methods. The third challenge is unknown attack patterns. Audit is a non-parametric algorithm which does not assume any knowledge about the attack characteristics. Because of that, it is able to detect previously unseen attacks as well. The fourth challenge is scalability. Audit can be run on multiple nodes or routers and it benefits from the inherent hierarchical architecture of an IoT network. It combines local statistics to ensure security at a global level. Moving on to our testbed setup, here we have 15 different types of IoT devices such as a laptop, some smart switches, a security camera, an Amazon device, a Surface laptop, and some Node MCUs. We also have a Raspberry Pi which acts as a control server. The purpose of this setup is to show that an intrusion detection system running locally can detect even small scale attacks which globally can make a large impact. So moving on to our algorithm implementation, we see that the first graph is the audit statistic which is computed by a proposed IDS. The second graph corresponds to the total number of packets being sent over the network per second. The third and the fourth graph refer to the total number of packets from attack device 1 and 2 respectively. The attack devices are two node MCUs which send data at a slightly higher rate. The x-axis in all the graphs correspond to time with one instance being equal to 1 second. From the graphs, we can observe that the network is heterogeneous with total number of packets having a wide range with a minimum of 150 to a maximum of over 800. As we can see from the first graph, the audit statistic is still well below the threshold value, giving zero false alarms. We begin our attack at time t equal to 80 seconds. Now let us take a closer look at how we begin our attacks. The compromised devices check the status with the control server, which at the moment shows nominal. Once we begin the attack, the status is changed to anomalous, which signals the compromised devices to slightly increase their packet rates. As we can see, the status has been changed to anomalous. So we noticed that as soon as we started the attack, the audit statistic started increasing at a steady rate. Once it crosses a certain threshold, we raise an alarm. The threshold is a design parameter which can be chosen as per system requirements. Also, we can clearly see that the total packet rate and also the individual packet rate of attack devices do not increase considerably. Hence, such low-level attacks can easily bypass traditional intrusion detection systems which are based on packet rates. These kind of low-rate attacks might not cause a very severe effect to the network. However, they could still be quite threatening due to the ease of performing large-scale DDoS attacks by compromising millions of low-security IoT devices and having them synchronously attack a target only with low rate increases in local traffic. Now let us take a closer look at how audit mitigates the attack. Once the attack is detected, it computes the mitigation statistic after a given window of time. The mitigation statistic shows which devices have an anomalous behavior and are thus causing the attack. As shown by the bar graph, device 2 and device 6 are the anomalous devices and they were the attack causing ones as well. Hence, from the video, we see that we were able to timely detect the attack without causing any false alarms. We were also successfully able to detect the attacking devices. Also, without having any prior knowledge about the attack, we were successfully able to detect it. We also demonstrated that the proposed intrusion detection system can be implemented on a local level, which can then collaboratively detect an attack at the global level as well. Thank you.